Welcome, everybody, to our industrial 3D printing webinar about the new F3300 and using additive manufacturing, 3D printing in the manufacturing space. We'll give people just another moment to jump on. We've got a good number here. Welcome. Thank you for coming. Quick housekeeping piece. The chat is kind of for all of you guys out there watching. The Q&A section that you see on the right-hand side, that is where you can actually pose questions to the panel when we get to the panel section. And we've got a good number of people here, and it is time to begin. So without further ado, pull up my presentation and we'll get rocking. And it works. Come on, technology. Yay! All right, good. So here is the F3300. It is a beautiful machine. I just think that they did a great job with the design of this system. And the best part is it is made for speed, and we'll get into that. First, a quick introduction. I am Joseph Miller, application engineer out of Atlanta. I've been working with Stratasys 3D printers for 15 years now, and they're still just so much fun to play with. We also have Jeff Lendermon, a simulation specialist with GoEngineer as well. Before he was with GoEngineer, he worked with injection molding for 30 years. So a great source for manufacturing experience. Richard Cromwell, my fellow application engineer, he worked with custom manufacturing and repair of pianos, Steinway pianos, right, Richard?
Yeah, that's correct.
Yeah, for a lot of years, and then joined GoEngineer.
Yep.
So very, very cool stuff there. And our special guest, Chris Rolag from Stratasys, who is the product manager of the F3300. Before Stratasys, he worked with composite materials in spaces like aerospace and automotive. So we've got a lot of good experience here to speak to this new product and how we can use it and other additive manufacturing tools in the manufacturing space. So the purpose of GoEngineer is really to help our customers have fun tools to create their products. Everything from SolidWorks to 3D printers. We have multiple partners, especially Stratasys and SolidWorks, but even some 3D scanners and even metal 3D printers. We have a lot of helper tutorials on YouTube and even online training, in-class, in-person training that are available to all of our customers and everyone online. We have more than 60 offices coast to coast. We are nationwide, so somewhere close by, there's always going to be one of us to help you out. I know the guys over in the customer portal wanted me to give a shout out to the user portal. It is a great space. You can jump on, manage your companies, customer accounts, user licenses, trainings, all of those features that you get from us right in the customer portal, including a way to stay connected, get questions answered 24/7. So if you haven't seen the customer portal in the GoEngineer community, jump online, goengineer.com, and check that out. And it's a really great space to go. All right, into the meat of it, the F3300. What is it? Why is it cool? And who is it for? This is so fun. They did so many changes for this. First up, what is the F3300? Well, it is a regular FDM printer, I say regular, they've actually made quite a few changes. The first is they're going more metric, and in my mind, when we're dealing in accuracy counts of microns, metric is kind of the standard we should be in anyways. So the F3300 has a build area of 600 by 600 by 800 millimeters. And for those of us who are still working on our mental calculations on converting that, it's about 23 and a half by 23 and a half by 32 and a half inches, really close to that. So it's a good size printer. It's going to start with 4 materials. They say start with, so I imagine more are coming, just not available yet. And those will be ASA, polycarbonate, nylon 12CF, and Ultem 9085. These are the most common, most used manufacturing type materials. That's why they started with those. The soluble and breakaway supports will be material dependent, whichever materials can use whichever support options available. So on the surface, an FDM printer, but they made a lot of really cool changes. And I'm just getting to know it myself. I have not yet seen one. I'm really excited to, but let's go through some of the new features. Why is it cool? Well, first, it's up to 2 times faster. We're going to touch on some of the reasons that it is faster. One of the more important reasons, I think, is even the reliability increases over the Fortis 450s and Fortis 900s. Reliability and repeatability are super important in manufacturing. So getting these types of figures for this printer is really speaking highly to its proposed use. Up to 45% lower cost per part. That's huge. And a lot of the things they did for this, there's a lot of figures that go into that number. But one of them is just the ease of use that it has with this. A lot lower operator costs. There's a lot less hands-on time with it. The upper section of the printer is an all-new gantry system based off of high-end CNC linear rails, components, gear systems. It's all new and able to move faster. And even connection for MT Connect for all of the data, especially if you're creating end-use parts that you have to track and keep records of the manufacturing process. All of those things are built into it. Here's the biggest time saver on this is the auto calibration. I'm really excited about that. I've changed tips hundreds or thousands of times on the Fortis printers, and it can take some time. It's not a big deal when you kind of do it a lot, but when we're talking time is money, auto calibration is really cool. There's no auto change errors. The way they worked out the system is going to take one material to one head, so you don't have to swap back and forth going to the same extruding point. So auto changeovers errors are going to not be an issue. Onboard material dryers. This is really big. You can not worry so much about the material you're putting into it. Lower cost, larger spools. The old spools for the Fortis systems were 92 cubic inches. These are 4,100 cubic centimeters. Let's convert that to give a direct comparison. That's 250 cubic inches, more than double. So that's going to lower the cost of each of the spools of material. Multi-material printing possible with the individual print heads to individual materials. We'll see some closer pictures of that in a second. I think that's just awesome. All materials will be included with the purchase of the printer. There's not individual material licenses for it. Very, very neat. Here is, at least from my experience so far, the real heart of improvements, at least the visible ones, to the F3300 is this new extruder design. It's a modular system, so you have the hot end or the tip if you're used to the Fortis machines, the extruder assembly, which would be the main drive gears for the head, and then a head bracket assembly. And it's really neat. They based it off of automatic tool changing systems like in high-end CNC machines. So you can now just put together the head combination you need for a material, slap it in there, and then the printer itself will actually go and grab each tool head and use it as needed. Just a really neat design. Because of this, there's also one head per one spool of material. So you can load up even 3 model materials to 1 support material, something you couldn't do before on the Fortis printers. You can have different colors of the ASA to print multicolor objects. You can adjust, you can use different types of materials as long as they're the same temperature profile, right? But all of these things are available because of the 1 spool to 1 head setup of this. I think it's just awesome. Also, when the tool grabs the head, it's translating in Z. It grabs it and then it has to pull the hot end down into the print area. And because of that, as it's printing, it can also make adjustments in the Z as it's printing, speeding up those layers so you don't have to wait so long for the large, heavy Z stage to move down. There's just so many cool things with this. It's very awesome. Multi-resolution printing, again, with the head being able to translate in Z as well. 3-layer options, including a newer one that so far has only been available on the 900 of the 20,000ths layer thickness. Here's a closer in image of this head, the upper portion of it with the heads. So you put in your hot end, you put it into the extruder, you put the extruder into the cradle, and then the printer will come and grab the tool it needs for each part of printing as it needs it. The documentation I've been reading for this printer compares the Fortis printers about a 1-minute changeover from model to support, 60 seconds. The changeover from a model to a support material with this in this method is 15 seconds. That's 45 seconds every layer that it has to change back and forth from model to support. If you're printing a couple thousand layers, that's a huge time savings. Really neat machine here. Okay, who is it for? Well, first and foremost, this is designed and built around people who are making parts to use, not just prototypes. You certainly could make prototypes with it, but it's really geared around people who are making parts that are making them money, actual end-use parts. Okay, finished parts, service bureaus, whether that's finished parts or prototype parts, service bureaus can make those parts faster. Anybody who's making manufacturing aids, jigs, fixtures, alignment guides, go, no-go guides, assemblies, component trays, all of these things are going to be able to be printed faster and at a lower cost on the F3300 compared to the older Fortis machines. Metal stamping forms, etc. All of these types of manufacturing aids can be built and built faster. Who else is it for? Anyone who is using these parts and you need to reduce the cost of the parts. When we're talking about additive manufacturing, we're not talking about printing millions of parts. These are usually a couple hundred. Just a simple injection molded plastic doohickey part, you can print millions of those and sell them all over. But if you're talking airline parts, you might only need 100 of that part. So keeping those costs low is very important. High throughput, you do need a lot of parts, especially a lot of different parts. That high mix, low volume ratio, lots of different parts. It's real easy. You don't have to go and cut tools and manufacture the molds or anything to get your parts. It can just print the part. There's data feedback that we talked about, the MT Connect. Low operator time, the automatic calibration, the quicker changeovers with the multiple heads to individual spools, larger amounts of material per spool, so there's just less hands-on interaction with it. Okay, and of course, reliable, repeatable parts. All of these are coming into the F3300. Now, I know that's kind of a lot of info thrown at you really fast. It's okay. We're going to have a little time for our Q&A here in a moment. And please remember to not use the chat for the questions. Go into the Q&A section for those chats. And this is a very new printer. Again, I have not yet had the opportunity to play with it. Chris will give us some insight into that here in a few minutes. And whew, that was a lot. F3300, friends. Really cool stuff. Now we'll jump into the questions from our panel. Let me go into the screen, and there we go. Perfect. All right. So here in our panel discussion, I'm going to take us through more or less the manufacturing process, right? So we're going to kind of step through all of the major segments of any manufacturing job, at least as best we can. We do want to allow those questions from the live audience here to be important and come up in this session. So if we don't get to all of the manufacturing steps I've kind of planned out, that's going to be okay. We'd rather get these live questions here. So, but before we do that, sorry, I want to make sure, Chris, did I miss anything really important on the F3300?
I know. Thanks, Joseph. I think that overall, that was a pretty good overall highlight. I mean, the biggest thing to take away is it is a very different system because we're using a tool changer to actually switch from model to support. I guess it's worth pointing out with the 4 extruders, you can now use 3 different colors in the same build or 3 different materials. You can do 3 model, 1 support, 2 model, 2 support. It's not a predetermined 2 model, 2 support like we've historically done in the past. But you covered a lot of the highlights.
Well, good. Excellent. We've got one question here, if I can see how the share works. Cool, that works great. What are the costs of the Ultem and ABS filament spools approximately? Chris, do we have any numbers on that yet? I don't remember reading anything.
We do have numbers on those. I can tell you they're, for this system, because we're using the larger spool and it's actually an open type design, it's not in a canister, it's actually just in a spool. The cost is about 25% less than what it is on Fortis because we're getting the advantage of a larger spool with actually on a per cubic inch basis, I should say. So 25% less per cubic inch.
Per cubic inch, okay.
For 250 cubic inches per spool.
Right.
And that's pretty much where it falls. So if you're familiar with your current Ultimate ABS prices, that'd be about 25% less than Fortis.
Okay, awesome, great. We've got another one from Kevin. Got that? Okay. From Kevin, for the speed of the part cost, speed and part cost, what are the 2x and 45% comparisons to? Some of that is the material, like you were just talking about.
Yeah, I'll elaborate. I did put the pick quick comparison on this was to the F900 is where we got most of our data. And really, we did look at other leading FDM printers from the data we could collect. And these are kind of up to numbers, so it's geometry dependent as always. Sometimes it's actually a little bit higher than that. Sometimes it's a little bit less. But on average, we are seeing significant speed increases, and the cost tends to be in that 30 to 45% less.
Okay.
On general.
Excellent. Thank you. And then one more here from Tim. Can you share some alignment in comparison to existing Stratasys competitive printers? Sorry, Tim, not totally sure what you mean by alignment. You mean I assume you mean one-to-one comparisons per part. If you've got anything right handy, Chris.
I think I do. So I've got a little check gauge actually here at my desk here. This is a check part we build on every machine. I can tell you I'll give you a couple different numbers. On the Fortis 900, this takes 3 hours and 43 minutes. I believe 3 hours and 43 minutes. On the F3300, it takes 2 hours and 7 minutes.
Wow.
So you can do that math. We did do this also on one of our competitors, and it took 4 hours and 39 minutes. So like I said, we are close to about half the time typically on a part like this. Now, it isn't always the case. Trying to look. There are some more complex parts where you get in. This isn't a great example, but when there's more detail, when you're printing on the smaller features, you have a minimum layer time you have to deal with. So you don't get quite the same time savings. When you have those long beads where you're printing these long panels or thicker beads, you're going to get much faster printing. That's where you take advantage of the speed. But if you have to wait for the plastic to cool off, you lose some of those gains.
Right.
Yep. There's physics involved.
Right. Excellent. Well, thank you.
Yep.
All right. Those are our current questions. Feel free, friends, to put those in as they come up. We'll jump back to kind of our imaginary scenario of a company who's trying to bid on a job, get some work, and has this ability to use 3D printing for it. So we'll start off with Jeff. So Jeff, you've been in injection molding a long time. You've worked with a lot of bidding on jobs. What are some of the difficulties you faced bidding on a new job, determining if it's worth your time, and with injection molding being your tool?
Right. A lot of times, depending on the customer, I worked for a custom injection molder, so we had our specific base of customers. But when you get approached by someone that's, here's my new design, inventor type guy or something like that, newer designer, it was always the poorly designed plastic part for injection molding, and also the sticker shock for the price of the mold, what it's going to cost. And they come up and say, well, how many parts are you going to produce in a year? You get 2,000, 2,500, stuff like that. It's like, well, you might end up with an aluminum single cavity tool or something in that case. But I found we had a Stratasys Dimension old 1200 printer eons ago that I used I would 3D print their part model and then sit down at the table with them and say, okay, we need to add draft with a marker. We need to add draft here. See this little thin web? That's going to be a knife edge in the mold. We need to do something with that design. Can we do this? And then just sit down with them and go through those things. And it made it easier for us to quote the tooling, and it helped them understand their part design. We did that over and over. The other part with quoting, talking to my tooling guys that were going to build the tool, we would have a meeting for how are we going to quote this thing, and they would have the part in hand that's 3D printed, so we can look at it and they can imagine where the shutoffs and all those things are going to be for the tool. So it definitely helped us in those cases.
Excellent. Yeah, I imagine, especially being able to sit down and say, here are the
Exactly. Yep.
pieces, just being very visual.
Yeah.
Excellent. So now we've kind of got that portion. We've found a job. We're bidding on it. Chris, what kind of flexibility can there be in materials? If a customer comes in and says, hey, I want this in ABC material, is it pretty easy with your past experience in materials to be able to say, well, this material will do the same job and is cheaper or more available, things like that?
I mean, it really depends, of course, on the requirements of the specific job. And with this specific printer as an example, we picked kind of a range of materials specifically to cover the different applications you might see. So with ASA, as an example, ASA is very similar to ABS, very similar performance. You could probably swap an ASA for an ABS pretty easily. You also get the colors, where if you need the high temperature, you're looking at the Ultims, or if you just want stiffness, the nylon 12 CF kind of falls in there. So there's options to cover a broad spectrum initially. If you want to get more complex materials, there is still other system options out there.
Right.
450, 900, etc.
Yeah. Okay. So, Jeff, did you run into this at all, where a customer would say, I want this material, but it's really not the right one for them? Or
Yeah. A lot of times the materials that were chosen were really for their applications. We had downhole tooling that we did. We had medical electronics and things like that. And in fact, with the 4 materials that we see with the 3300, I was looking at them. The ASA is good for electronic things or things that are going to be outside, because it actually it doesn't get attacked by the sunlight like the butane
UV
that's in
resistance.
ABS.
Yeah.
And then nylons, we did a lot of glass-filled nylon stuff for downhole things, or also Ultim stuff for downhole things as well. And then polycarbonate in the medical industry. So all of those things, just those 4 materials cover a wide range. So it's helpful to have that in the 3D printing, but I mean, there's so many different engineering grade polymers you can injection mold. That's where you're getting a little smaller gamut, but those 4 to start with are great.
Excellent. Yeah. Richard, you've done a lot of low volume pieces. How has low volume manufacturing benefited from an additive manufacturing process?
Well, just carrying along with the injection molding idea as an example, right? Is the volume of the product is low, to offset that the cost of the high tooling, they'll pass that along to the customer, right? And so a lot of the time that would make that really an unfeasible business enterprise, because no one's going to buy it. It's too expensive. And so additive manufacturing actually allows you to produce products at low volume and still make them affordable. And not only that, but there's the aspect of being able to customize, every element of the part. You're not just married to whatever you've made that mold for. You can iterate on an individual basis. And like the perfect example of this happening today is personalized medical devices that are being made. And even like things like the TrueDent dentures, where it's a class 2 medical device that's being printed, and it's an end use part that goes in somebody's mouth. And that
cool.
type of thing, and that type of thing really wasn't even possible to do any other way than how we're doing it today. To make a fully polychromatic monolithic denture wasn't something that you can do with any other methodology.
Yeah, it used to be just separate, kind of close enough molds, and someone would have to find the close enough. But
you would have a highly skilled artisan that has dedicated their life to this practice of making realistic looking characterized dentures. But now we can print them in 2 hours and in $24 worth of material. So the idea is that and you know, that puts the people in that industry kind of on notice that they need to adapt or they're not going to survive. And as a guy that worked in the piano business, I'm fully comfortable dealing with that, you know, and discussing it because it's what I had to deal with too.
Sure. You sent me a picture of 3D printed shelf piece for a piano, but I imagine that was a one-off kind of piece.
It was totally a one. It was a one-off kind of piano. I think I think they made two of them. It was a 9-foot concert grant made by Steinway that had two keyboards. So if you think about it, you know, like a normal piano has 12,116, you know, individual parts. That piano had close to 20,000. And so, like I used to have a Saab convertible, and that thing only had 3,000 parts. So I mean, this is a very mechanically complex thing. That could no longer be manufactured. And that's why they came to us. And we ended up using a grant through the Discovery Institute to 3D print a part for it. And that's how I got into this. I was so blown away by that and realized that so much of what I was spending my time doing manually could benefit from digital manufacturing. And that's how I went down this path.
Yeah. Something that only 2 were made in the entire world. You can't find spare parts for that.
No.
So that's
and it was made
impressive.
in like the 1880s, you know.
Oh,
they're
wow.
long gone.
Yeah, that's incredible. All right. So, Jeff, when we talk about the first article, our first part that we give to a customer, how important is it to successfully fulfill that first article?
Right. Well, that's what your approval is going to be based on, your first article. So especially injection molding, you're approving the mold at that point. So you have the part design, we've printed the part, we've talked about what they're going to change. They make those changes to their part, hopefully, and then we have the tooling built. I was lucky in the case that the company that I worked for 22 years, we had our own tool shop as well. So we were building in-house tools. Over time, we started going overseas, offshore tooling and things like that. So we had better luck with our own tooling as we were building it and getting good first articles out of it because we knew we were building it exactly for our machinery. When with an overseas tool, you might get that tool back and the manufacturer sent you the first articles and you got them approved and everything from the first articles. Send them to the customer, they love them and everything, and then you go and stick it in your machine and you can't get a good part out of it. Oh. Either there's things that aren't machined right, or the factory that did the samples had them fixtured in such a way that they were shrinking, or it was an extremely long cycle time that wasn't efficient for us. So,
okay, yeah.
But getting the first article to the customer, those things are absolutely necessary to get your tooling approved. So, once the tooling is approved, then you can get into manufacturing it, right?
Right. Especially, I imagine, for a low volume run of something, someone has put out $10,000 to $50,000 for this mold. So if they then run into the problem of the first article was fine from a foreign tool manufacturer and come back and are producing it themselves or with a local manufacturer and have it not work.
Right.
Oh.
those are headaches.
Yeah. Ouch. Ouch.
But the manufacturing from overseas has improved quite a bit since then. I mean, that was over 15, 20 years ago, some of those things happening. So technology has improved, and the manufacturers over there, their quality has improved as well.
Well, good. It's always nice to see improvement rather than just lower costs, but no benefits. So we've got another question in here from Tim. Speed is great. Can you share any information on the part ethnicity? Have there been any compared to current printed parts? Chris, you did a little bit with that with your one example part.
Yeah, we're in the process now of doing pretty extensive part comparisons, not just in throughput studies, but as well as density, accuracy, repeatability. All those studies are in process right now. A couple interesting takeaways we're seeing is, in general, they tend to be a little bit more dense with the newer hot ends that we've developed, as well as some improved tool pathing involved in this machine. We are getting a slight improvement in the density, which has resulted in a slight improvement in the strength. So overall, the parts tend to be a little bit stronger. Accuracy is still in process with the part quality tuning, but it's right now it's right in line with the F900, the parts that we compare it to, with a target of getting it a little bit better, or actually quite a bit better when we're done. Let's see. So far the parts have been looking quite good. Yeah, we're still working through the process, but it's headed exactly where we want it to.
Excellent. Thank you. One more from Tim. Any talk about OpenAM for this printer? Only 4 materials seems to be moving in the opposite direction.
Yeah. So for materials is what we were able to get tuned in time for launch. There's a long roadmap of materials we'll do from a tuning perspective. OpenAM is in fact in the roadmap. We're just not launching with that, we want to stabilize the printer, get it proven with known materials, and then down the road, in the not too distant future, we'll open it up to OpenAM validated materials and grow the material portfolio as quickly as we can. But the first initial materials, it just takes us time to get them tuned so you can hit that easy button for each part.
Okay. And that the OpenAM is kind of working into this next question, no open source materials. So kind of the same
yeah, not right now, but
right.
long term, it is part of the plan.
Yeah.
And I guess I should highlight there are no licenses required. So as soon as we add materials to the machine, they'll be available to use.
Then right. Yeah, that's really nice to not have to then go through a whole purchasing cycle to get the new material. Yeah.
Yep. We want to make it as easy as possible.
Absolutely. Jared asks, what nozzle sizes are available, orifice and layer height? Chris, I read 2 different things on this. One of them said 4 layer heights, and the other one said 3. That's what I went with.
It's a timing. It's a timing thing. So I'll say, initially, all the materials will have a 0.25 millimeter and a 0.5 millimeter. So for you English units guys, it's 10 slice and 20 slice. We'll start all the materials will have those 2 for sure. Some of them will have a 0.188 millimeter. Which is like a 0.7 slice.
The 7. Uh-huh.
Yep.
Okay.
And then, so those 3 are the ones we'll have at launch, and then very, very quickly after that, we'll split the difference between the 10 and 20 slice. We'll have around a 15,000 slice coming, and then it's just a matter of how quick can we tune on those different slice heights.
Right. So, okay. I've played with the OpenAM some on my 450 here, and it is a bit of a process to go through and print a test part and measure it and everything. So
yeah, the trick is being able to account for every geometry. That's where it gets tricky. Right.
Then Kevin also asks, cost of the 3300 and service plans.
Price point wise, its base price is very similar to the F900 from a starting point. The difference is you don't have to add a whole lot on top of it, so it kind of includes everything to begin with. And then from a service plan, there are some service plans available. Again, very similar to what you'd see on an F900 price point.
Yeah, makes sense. Perfect. All right. Thank you for that. And thank you for the questions. Please, by all means, throw them in the Q&A as they come up. So moving on with our process of manufacturing, we've gone through the bidding on the job. We've gone through kind of the first article, the prototypes, low volume versus high volume things. So Richard, there can be a lot of steps in getting a new product to function correctly, especially when you're working on a low volume thing. How are the stakes higher for that low volume production versus something that's going to have millions of copies made?
Yeah, it's going to be the cost of bringing the product to market and the time, right? You have to shorten that as much as possible because of the low volume. or else you come back to that same scenario where you're going to have to increase the price and potentially, put yourself out of work. So it takes. I look at it this way. When you're designing a product and you're making something, you have to. It's a mix of art and science, right? And because we're designing something, which is the artistic element, but then we're trying to meet the constraints that are put upon us, whether it's financial or geometric or whatever. And the additive manufacturing allows us to meet those goals a lot faster. When it comes to, but the question is like, how many cycles does it take? I like to look at it, the art portion. Leonardo da Vinci once said that art is never finished by the artist; it's only ultimately abandoned, right? And so I think that that's true for people that design things as well. But really, the ultimate end is when you have the buy-in of the stakeholders or the customer. Once you have that, then now it's time to move forward. And if that changes, then it might require going back to the cycle and reiterating again.
Yeah, I know you've done a lot of low volume things, both in your previous business and now you work with a lot of technologies. In your experience, what is your preferred method for doing those low volume parts?
Okay, so that's a great question, and the answer is a little bit dependent on what the application is, right? Because that will determine what material we're more than likely going to be choosing, and then the technology itself. And because nowadays we have so many different technologies that are capable of producing very useful parts. Even like I said, who would have thought, 5 years ago that you'd be printing end-use parts on a polygon machine, let alone ones that go in somebody's mouth. But if I had to say, you look at SAF as a great opportunity for mass production very, very quickly of 3D printed items. But I'll be completely honest. My favorite is the ones behind me. I love the Origin one. I love P3. The level of detail that I can get out of these machines is absolutely incredible. And then the material choices are actually generally useful materials. I mean, you can print a sledgehammer on this and it'll break concrete. So and then light it on fire and it won't burn. It's really amazing stuff.
Excellent. Chris, we're going to kind of roll back around. Looking specifically at the F3300, how can additive manufacturing help companies save time and reduce costs, both on end-use parts as well as manufacturing aids?
Sure. So, there's a few ways, I guess, specifically what's different about this machine. One is it's very simple to use. It's very automated. So you're going to save some costs just by the reduced labor there is to operate. When you load up the machine and hit go, all the calibration, all the changes, all the work happens after that. So you literally hit go and you walk away. It takes about 5 minutes. You load in the spools, you load the heads, you load your part, hit play, and then you come back when it's done. So it's very quick, and that's for any part. You don't need to buy tooling. You don't need to do any setup. So from I have an idea to I have a part is even faster now than it used to be. So you're going to save money and time just because of the simple reduction in labor and then the faster print time. So you kind of combine those two things, it leads to a much better business case for a lot of specific parts in manufacturing, and especially manufacturing support. Kind of getting to your question, when you need something on the shop floor, you don't want to mess around trying to redesign and tweak it until you get it to work. That's why we do the tuning ahead of time. You get your file, you print it, and it'll work the first time. So, and it's a lot faster now.
Yeah, I still love the stories from Ford and from BMW on just the ergonomics of applying decals to things. Yep. Something that most people wouldn't even consider as a major component of car manufacturing. But if your assembly guy gets a strained wrist, that's going to slow down your whole production. But if you fix just that one little thing with an overnight build, I still love that story. It's
Yeah,
pretty great.
so we are just starting to play with some colors and stuff, but like this, because we can do multicolor in this printer too. You can print a fixture or a guide. You can put the part in here, and it'll actually do it in color now, which we haven't been able to do before. So
Yeah,
just
which
some
is
new
really awesome.
new play we haven't had before with this machine.
Yeah, excellent. Well, friends, we are hitting the end of our time. I just want to open up real quick to any last thoughts or comments to the panel. Jeff, anything from you?
Not really. I thought of something, but then I was thinking, because you have the 4 heads and different materials, I mean, technically you could print 2 different parts with 2 different materials at the same time.
Within the same temperature range, right? So you can't print.
Right. Okay.
You could we've done it where you have 2 different colors of ASA in the same build.
Right.
You can do it. You could do a filled and unfilled material. So you could do a nylon 12 CF and a nylon 12. You could also do that in the same part, by the way. It doesn't have to just be different parts.
Which, yeah.
But as long as they're within the same oven profile, you can look at that long term. As we add materials, that's one of the things we're going to look at. Right now, it's kind of limited to just multicolor because of the materials we selected are different enough. They don't really combine.
You're still only printing one at a time. It's switching out.
Yep, you're printing one at a time with the 4, but they are heating and cooling on the rack, so your changeout time is very fast.
Yeah.
And you can lay them right on top of each other. So same part, different parts within the same temperature range. You can do different things.
That's really awesome, Richard.
Yeah.
Any last thoughts?
Well, I'll tell you guys that I'm really excited to actually see this machine. I've lived with a Fortis 450 for many years, and now we have like F900s and 450s all over the place. So I'm looking forward to adding, hopefully, this machine to our lexicon of tools here, and it looks amazing, and I'm just really excited to see.
Excellent, thank you, Richard. Chris, anything to send us off with?
No, I'm super excited. I can't wait till we start shipping these to the general public. We're still doing that final testing, making sure we hit all of our reliability requirements before we send it out. But thanks for having me today. It's been great to talk about, and I look forward to getting one in all your hands.
Yeah, it's exciting. Thank you to Jeff, Richard, and Chris for joining us today. It's been a lot of fun. Thank you, audience, for your questions. That really helps us have good interaction here and get good information out to you, because I can't think of everything ourselves. We've got a lot of expert blind spots, so your questions really help us out. And with that, we will say until next time. Goodbye.
Bye, guys.